Hey guys, welcome back. So today we're going to do two more free response questions. And these are a little bit more challenging, but also very possible on the AP exam. Now for you guys who are at home, I want to make sure you understand the layout of the AP exam, okay? And you can look all this stuff up yourself on AP Central or whatever they call it these days. So your exam, the free response questions, there are 6 free response questions similar to this, okay? 2 of them are with a calculator and 4 of them are with no calculator. The 6 questions, each one of those 6 questions is worth 9 points. So altogether on free response, there are 54 points. Then on multiple choice, you have 2 multiple choice sections, one that's calculator, one that's non-calculator, and the number of multiple choice questions is about 50 also. So they basically count equal. So you want to know every time I say a point for a free response question, 1 point is very similar to 1 multiple choice question. Some of the points that you can get are real easy, like writing the units when they tell you to. Some of them are hard to get. So also keep in mind that to get a 3 on AB for calculus, you really only need to get about 50%. So if you can get 50% right, you're looking good, and then your goal is to build up from there. Okay, so please take a minute, hit pause, really read this question. The big thing with the free response questions is you have to know what all of your variables actually stand for. You have to read the given information and try to get an idea of what the heck they're even talking about so that you know what they're asking, okay? And again, really pay attention to the variables, and when you're differentiating, make sure you note this tells you what you're allowed to differentiate, but it also tells you what you're allowed to integrate, both of those things. Okay, so hit pause. Okay, so let me go over a few things that you should have gotten from that. First, W is the solution to this differential equation. W represents the amount of waste. Okay, well, dW dt, therefore, would be a rate, how fast the amount of waste is changing in time. Okay, so this is a rate right now. Also, the amount of waste, or W, at the beginning is 1,400 tons. What does that mean? It means there's a point, W of 0 is 1,400. Okay? So keep an eye out for the difference between W, which is the amount of waste, versus dW dt, which is how fast that waste is changing. Okay? All right. Next, some other hints. I don't want to do that problem for you, so I made up one that's super similar to it. Okay, but I'm just going to focus on variables, okay? We've been integrating, separating variables, and that's going to be part of the question too. Make sure you know which part it is, particular solution, okay? So we know when we integrate, the dt tells us what has to go on the right side, okay? So we can leave the 1/5 here, or you could distribute before you start. Either way, I'm going to leave it there. I'm going to move my k's to the left. So I have 1 over 100 minus k dk is equal to 1/5 dt. That's the same old, same old. Okay, the next thing I need to warn you of is make sure when you integrate, always remember to divide by the derivative of the inside. So on the right side, we have 1/5 t plus c. You got to write the plus c at this stage. On the left side, this is the natural log of 100 minus k. Divide by the derivative of the inside. Now, honestly, if you look at the scoring, most of the time, the little bit of work that I just did gets you 4 points, okay? Typically, you get a point for, first of all, separating the variables, okay? That'll be 1 point. Then on the right side here, that's often 2 points, one for the antiderivative and one for the plus c. And then on the left side, another one for the antiderivative. So this one little question is usually, just part C, is often 6 points, and getting just to this point is a lot of points, okay? So then from here, multiply by -1, exponentiate both sides, and make sure you solve for c. I'm not going to continue with that. What I wanted to make a point of is the variables, okay? So we just started the process of getting the particular solution and integrating with separation of variables. Now let's say they ask for the derivative. So for some reason, you want the second derivative. This is already the first derivative. Now we want the second derivative. Okay, let me erase this and go back to that point. Okay, so back to the top. Again, if this was, I don't know what K even stands for, amount of kangaroos, I don't know. So K would be the original function. dk dt would be how fast it's changing. But for some reason, they ask for the second derivative. So now I need to do the derivative of this. Okay, well, to do the derivative of this, I think, first of all, I will distribute. It'd be a little easier. So I'm going to rewrite that as 20 minus 1/5 K. Okay, well, now I'm doing the derivative, but you're doing the derivative with respect to time, not with respect to K. So remember when we did related rates, okay, if you had this equation, okay, the derivative with respect to time would be 2x dx dt, 2y dy dt. Okay, so if you're doing the derivative with respect to time, then you have to differentiate only t's. And if it's not a t, you need to tack on a chain rule. Now, also at the same time, I might as well review implicit differentiation. If they said they want dy dx, now I can only do the x's. So 2x is normal, but the y would be 2y dy dx. Okay, those are the different ways we've done it. But it all comes down to what it's with respect to. So if I'm doing the derivative with respect to time, then if it's not a t, then I have to tack on a dt. So for this one, when I differentiate this, the derivative of 20 is 0, but the derivative of this is -1/5 dk dt. Okay? And then you typically take this dk dt and replace it with the dk dt that you already know. And then you'll answer the question and use it somehow, okay? So that's a big one. That's a tricky one. So that's what's going to happen in today's problems. So back to 2011. Again, I'm not working out. I'm giving you some hints, okay? Remember, to find the worked out solutions, you guys can Google all of them. You can find a teacher teaching them. All right, so part A. Equation of a tangent. Well, you know you need two things, point and slope. So at time of 0, what is the point there? Okay, well, hopefully remember, of W, that point would be at time 0, there's 1,400 tons of waste. There's your point. Your slope means, here's slope, okay? You're going to plug in these coordinates into the slope equation, but you really got to understand the variables for these. This was time and waste, okay? So that's giving you a hint. After you get your equation of your tangent using point and slope, after that, you then use that equation to estimate the amount of waste at t of 1/4, okay? Now, the next thing, part B, tell whether that estimate you made is an over or under estimate. Okay, well, that always has to do with concavity. Okay, if your graph is concave down or second derivative negative, which is what you would have to say, then your tangent is above it, and therefore your estimate would be an overestimate. If your graph is concave up, then your tangent is below it, and then your estimate will be an underestimate. So what you're going to need to do is find the second derivative at that point of tangent C. Okay, so our point of tangent C would have been 0, because that's the point we plugged in to write the equation of our tangent. And then the thing we plugged in was t of 1/4. So you're going to have to find whether your graph is concave up or concave down at 0 or at 1/4, okay? But what you need to state is, my second derivative is positive or negative, therefore an over or an underestimate. But you have to say that your second derivative is positive or negative on the interval from the point you used for your tangent to the point you plugged in. Here's why. that curve could very well be both concave up and concave down. So you've got to state that it's either concave up or concave down on the interval that's in question. Okay? Hopefully I'm hinting without being super duper clear, because I want you to still work this out on your own. Let me go back to the question, okay? So in part A, you're writing an equation of a tangent using this point and slope at that point. After you write the equation, you're going to use it to estimate at t of 1/4. Okay? Then in part B, find the second derivative, figure out if it's positive or negative at this point, and make sure you state whether the second derivative is positive or negative on the interval from 0, the point we used when we wrote the equation, to 1/4, the point that we estimated. Okay? The last part should be pretty clear. We've done that a bunch of times. Good luck. Again, there's videos, lots of teachers teaching these. You can look up an explanation of all of them. The next one after this that I assigned is very similar to this. Okay? Good luck. Hope you're doing well.